Good morning, Morgan, and good morning to any of Morgan's friends that have joined this video. Today, in lesson 24, we're going to talk about dictionaries. What's a dictionary? It's another way of storing data. It's another data storage object, just like a list or a set or any of the other ones that we've dealt with. This one, I think, is similar to a tuple. Okay? And here in this example, we are creating a dictionary. And apparently, whether you use curly cues or brackets or parentheses determines what type of object you're making. So for the dictionary, we're using these curly things. All right. And what's interesting about this is every member has two values. In this example, maybe you can have 3 or 4 values. I don't know. But here we have two different data types mixed. One's a string and the other is numeric. Okay, and in this example 1, we're creating a dictionary with these two members. Now, before we go on to reading the documentation, let's just take a look at this sample code. I'm going to pause so that you can take a screenshot of it if you want to copy it. Here in this one, we're going to be creating the dictionary. In example 2, we're going to be adding data to the dictionary. And here we're going to actually look up data that is stored in the dictionary. Then we're going to delete information out of the dictionary. And then we're going to add data to it again. And then we're going to use this list function with the dictionary's input to it. And then we're going to use the sorted function to sort the members of the dictionary. And then here we're using an if statement in conjunction with the dictionary so you know how to use it in your tests. Well, where's the test? Oh, it's inside the print. I'm so sorry. All right. Anyway, enough of that. Let's go ahead and go to the manual and get some reading in. All right. Now it's time to do the part that I don't like the most. And I'm guessing maybe you don't either. But it is necessary to deepen our understanding of how the code works. We cannot rely on our intuitive nature to guess what these functions do. We need to actually read the manual, even though we know that this is going to verify in our minds things that we already know about it intuitively. There are things hidden that will only be revealed to you when you read the manual. So, with that said, let's go.
Python Training Video 24 Dictionaries. Another useful data type built into Python is the dictionary. See Mapping Types, Dict. Dictionaries are sometimes found in other languages as associative memories or associative arrays. Unlike sequences, which are indexed by a range of numbers.
Okay. Associative memories, associative arrays. Okay, these are made-up words. Okay, this is what happens when you allow people with English literary degrees to get involved in programming. Okay, they complicate everything because they want to freaking create new words to describe the same thing. All they're talking about here is tables. And this is essentially what the dictionary is. It's a table. All right? With that said, let's continue.
Dictionaries are indexed by keys, which can be any immutable type. Strings and numbers can always be keys. Tuples can be used as keys if they contain only strings, numbers, or tuples. If a tuple contains any mutable object either directly or indirectly, it cannot be used as a key.
Okay, let's talk about what a key is very quickly. Okay, when you have a table, because that's what all these things are, okay, you have to have a way of identifying each record uniquely. Just like your house has an address like no other address in your town. You have to have a unique address to identify the record that you want in the table. We call that a key. And the value in that key cannot be the same. It has to be different from all the other keys. Every key has to be unique. Now, with that little bit, let's continue.
You can't use lists as keys, since lists can be modified in place using index assignments, slice assignments, or methods like append and extend. It is best to think of a dictionary as a set of key-value pairs, with the requirement that the keys are unique within one dictionary. A pair of braces creates an empty dictionary. Placing a comma-separated list of key-value pairs within the braces adds initial key-value pairs to the dictionary. This is also the way dictionaries are written on output. The main operations on a dictionary are storing a value with some key and extracting the value given the key. It is also possible to delete a key-value pair with del. If you store using a key that is already in use, the old value associated with that key is forgotten. It is an error to extract a value using a non-existent key.
Okay. Notice what she said about when you try to override when you try to put in a new member into the table that has the same key value as the one you're trying to insert. You don't create a new member to the table, you overwrite the old value pair. Okay? And it doesn't give you any warning about this. Okay? So I'm going to highlight this because this is a place where you might make horrible errors in your code. Okay. All right. Well, here we are in the output of the Python program that I showed you earlier. Okay. And looking at the output, you should kind of get a feel for exactly how these print statements work that I'm using to create all this code. But I'm doing it like this so that we can go through the examples that they showed us in the document and that you can have the code that works. All right, so here we are. Here's the command that we use to create the dictionary. Then, if we were to print the dictionary, it would return this. Okay, so you just see the same thing here. Now let's move on to the second example. Adding a member to the table or dictionary. Simply, here we have, remember it says key value pair, key value. Here's the key, Guido, which doesn't exist currently. All right, and this is equal to 4127 will be the value of the key value pair. Okay, all right, and this is how you create it. Okay, see the little freaking blocky things. All right, you have to use the exact character. It's not going to work. All right, and then we go check, and sure enough, Guido's at the end. All right. Example 3. What are we going up? We want to see if we can find what. So we're going to read the table. So we want to know what the value is associated with the key Jack, and it returns 4098, which we know is correct. And then we go into take a look at what's in the table, and look, it hasn't altered anything. Okay. We just read it. We didn't destroy any data. But that's about to change. Because this is how you delete a member from the dictionary or the table. You just add a delete on the front and you lose the equals thing. See how that works? Then we go and we take a look, and sure enough, Sape or whatever his name is gone. All right, so he's gone. And we go to the next example and we go like, let's put Irv in there now because we need someone to replace Sape. So that's what they do. This is how you add. We've done this before in an example, but repetition is a good thing. All right, now here we're using the list to see the keys, all the unique keys, right? And sure enough, here they are, right? Now we use the sort and we sort it all. Okay. You know what I should have done? I should have had another display here that shows you that everything was sorted. I'll do better in the next video. And now, how to use it in an if statement. Okay. Well, you go, well, I lost a little comma here, but Jack's maybe is a better thing. Is Jack not in the dictionary? Well, Jack is in the dictionary, so that returns false. That's one of those reverse freaking double negative logics, which is so hard to follow. But here's a simple one. You know, this is the truest one. Is Guido in the dictionary? Yes, true. Remember, these if statements return Boolean values or binary values. It's either true or it's false. It's either 1 or it's 0. Okay, and with that, the video is done, and I will see you in the next video. Oopsie, wrong button.